Hello, this is Mr. Huebner with Balancing Redox Reactions. I don't normally wear a mask, but it's 2020, and so that's why. What we got going, we had a little issue. We are doing the first method. We're going to run through it real quick. If you need to pause, that's great. You have to write all the oxidation states. Once you do that, let's zoom on that, you have to figure out what's being oxidized and what's being reduced. So in this situation, we found that copper is going from 0 to +2, therefore it's being oxidized and losing 2 electrons. Whereas nitrogen is kind of spectating, but it's also being reduced to form NO2, and only 1 electron is being transferred. So then the next step is we got to balance the electrons. So if we've got 2 electrons being transferred, we need 2 here. So we're going to multiply everything by 2. And there we go. And then we move on to the last step of this part. It says complete the balancing by inspection. So I've got copper and 2 nitrates. So I'm going to write copper. Plus 2 nitrates. And technically I got HNO3. So I got 2 NO3s, HNO3, sorry. What else was I dealing with? I was dealing with electrons, plus 2 electrons. And then we've got copper is with nitrate spectating, and we just have 1 of them. So we're still with copper nitrate. And then what else is going on? We've got 2... Oh my gosh. Thank you. That would have been a terrible video. And then we got 2 NO2s and then 2 electrons. And your electrons should be the same on both sides if it's balanced. Otherwise it's not balanced. And just double checking, we got 2 N's. Oh, this is tricky. Technically we got 4 N's. 2 plus 2 is 4. Here we only have 2 N's. Oh my gosh. So we'll have to tweak this because some of the nitrates are being spectators. So they're not protesting spectators, they're just spectators. We got HNO3. Alright, so then you got 4 H's. Oh, and I didn't put the water here, so let's put the water back here. And we got to get 2 times 2 is 4. And that gives us 2 O's. We got 4 times 3 is 12. Here we got 2 times 3 is 6, 7, 8, 9, 10, 11, 12. So the O's are good. And the coppers are good, and it's balanced. So it's a lot of work to kind of do that. Could you just balance it right there? Probably. But this is showing the redox that's happening. All right. Moving on to the second part, which is balancing half reactions using method 2. And method 2 you use in certain situations, like if you are dealing with an acidic solution. And whenever the spectator ions are not present, that's when you're going to do method 2. All right, so first step is, you guessed it, write the oxidation states.
Write the oxidation.
There it is. So we got -2 for oxygen is times 4 is -8. What can we add to -8 to get -1? +7. You got it. And oxygen is -2, but there's 4 of them. 4 times -2 is -8. What can we add to -8 to get -2? +6. You got it. But then we divide it by 2, so each carbon individually is going to be +3. Manganese is +2, oxygen's -2, but carbon's going to be +4 because there's 2 oxygens. Compute electrons lost and gained and draw ties between them. All right, so this is where we draw. I guess we could rewrite it. That's a lot of work. I don't want to rewrite it, so I'm just going to draw the ties between. Mn is +7 to +2. So what's happening? Oxidation or reduction? Reduction. It's becoming more negative, therefore it's being reduced. And why don't we just go right to writing the half reaction for reduction. We've got manganese aqueous plus 7 reacts to form manganese aqueous plus 2. And how many electrons are being transferred? 5. Plus 7 to plus 2 is 5. And are they being lost or gained? Gained. So we put it on the reactant side. 5 electrons reduces that to Mn2+. Alright, going back to finding the oxidation, we're going from carbon. The oxygen is spectating, it's -2, -2. But carbon's going from +3 to +4. So that I know is oxidation because the other is reduction, but it's also oxidation because it's becoming a bigger number. It's a more positive number. So writing that half reaction, I'm going to do C2O4 aqueous. This is +3, and it's forming CO2, and carbon in that one is +4. And where does the 1 electron go? On the right side. Otherwise it'd be wrong. That's pretty much it for that. So then we got to do all of these little steps that is unique to acidic solutions. First, balance elements other than H and O. All right. First, balance elements other than H and O. Oh, that'd be like carbon. Okay. Or manganese. And manganese is balanced. There's 1 on each side. Carbon, there's 2, and here there's 1. So what could we put right here? Put a 2 right there.
Yes.
There you go. And actually, I'm going to put MnO4 right there just to help us out, because we got that MnO4 right here. That's about it. So then we go to number 2. Next, balance O atoms by adding H2O as needed. All right. Here we got 2 times 2 is 4. Here we got 4. So it looks like for the oxidation side, oxygens are balanced. But here we got 4 and here we got 0. So we got to add H2O. All right, going to add. And technically I got space for it right here. Is it all right if I just kind of smash it in here? Or okay. Because now I'm always flipping back. It's just awkward. All right. All right, so I'm adding H2O on this side so that I can balance the O's. But I got 4 O's, so how many H2O's?